I'm Prasad Naidu. Today we will discuss about the bioenergetics, like biomolecules, high energy compounds. These are the involved in this various metabolic product pathways. First of all, what is bioenergetics? So it will produce energy. So bioenergetics is the steady energy of changes, releases or utilizations in the biomolecule reactions. Reactions where energy is released is called exorganic reactions. Reactions where energy is utilized are called as endorganic reactions. Bioenergetics is the free energy. The term Gibson change free energy, some of the negative or positive or zero, that is neutral state. Free energy or ethology or entropy. These are the bioenergetics, and also we'll discuss about this bioenergetics, some of the high energetics, some of the low energetics. So how to discuss these bioenergetics? These bioenergetics are majorly involved into the metabolic pathways. Some of the free energy, coming to free energy, denotes the fraction total energy in the system available to do the work. Gibbs change in free energy, it is the portion of free energy that is useful to do the work. Standard free energy change is the free energy change the understand conditions. pH, like example, pH is 7 and 1 milliliter concentration. Like some bioenergetics Gibbs change in free energy, it predicts whether the reactions are favorable or not. The energy is available to do the work. Exorganic reaction is the negative reactions, endorganic reaction is the positive reactions, and equilibrium, that is neutral, that is zero reactions. So also enthalpy and entropy is the enthalpy is the measures the change of heat content of the system. Energy is released, absorbed. Entropy is a fraction of enthalpy that is not available to do the work. It denotes the randomness of product and reactants. So bioenergetics calling majorly like biochemical reactions depends the change in free energy, enthalpy and entropy. The ATP, first of all we will discuss about ATP. ATP is the high energy compounds. So coming to the ATP, ATP is the generations of currency of the cells. Then ATP is on hydrolysis yields the 7.3 kilocalories. This ATP is converted to the ADP and ADP is converted to the AMP. This ATP is usually utilized to nerve conductions, muscle contraction and sympathetic reactions. These high energy compounds like ATP and ADP, ATP is high energy compounds. Coming to the high energy compound, that means increase more than 7.3 like that. That is, those are high energy compounds. Some of the low energy compounds. Coming to the high energy compounds, like high energy phosphate, we are talking about the coming to phosphates, pyrophosphate, acyl phosphate, enal phosphate, and phosphogluconide and thioesters. These are the high energy bonds. Compounds is called as acid hydrate bonds. High energy compounds also phosphoenol pyruvate and phosphoenol creatinine and 1,3-bisphosphoglycerate and acetylenosyl methionine and ATP. These are the high energy compounds. Coming to low energy compounds are the ADP and glucose 1-phosphate and fructose 6-phosphate and glucose 6-phosphate. These are the low energy molecules, some of the high energy molecules. So what is redox phase? Coming to the what is redox phase? The electron flow unidirectional from the carrier to the other in the etc. The carriers are reduced when they accept electrons and get oxidized when they denotes to the other carriers. The reduced and oxidized forms some of the carriers referred as redox pairs. Redox potential is the tendency of the redox pairs to denote or accept the electrons. Electrons always flow from the negative to positive redox potential. So what is redox pairs and redox potential? So redox pair is the NADH and NAD and FADH and FAD. So H2O or O2. So NADH is 0.3 redox potential. The redox pairs is if FADH is 0.12 and H2O is 0.8. The ET is arranged in the increases order of their redox potential. So enzymes of biological oxidation like ETC, electron transport and it is involved with the biological oxidation. We are talking about biological oxidation. All the enzymes of biological oxidation belongs to the major classes of oxidoreductase. Oxidation means loss of electron, reduction means the gain of electrons. That is some of the enzymes we will get talking about here. Enzymes here, biological oxidation is oxidases, oxygenases, and hydroperoxidases and dihydroxyoxygenases. So these enzymes in biological oxidation classes like oxidases means cytochrome oxidase, oxygenases means monoamine oxygenase, deoxyoxygenase, and some hydroperoxidase like glutamine peroxidase, catalase. These are the hydroperoxidases, and dihydrogenases, that is aerobic and xanthine oxidase. Some of the anaerobic conditions, those are NAD linked and FAD linked and FMN linked. Some of the oxidases, these enzymes catalyzes the removal of hydrogen bond, some hydrogen substrate. The oxygen acts as acceptors of hydrogen, forming the water. Cytochrome oxidase is monoamine oxidase. Some oxygenases, coming to the oxygenases. Monoamine oxygenase mixed functions of oxidases incorporate one oxygen atom into the substrate, other is reduced waters. Cytochrome P is like tyrosine hydroxylase, and deoxyoxygenase is incorporated like both oxygen atoms and the substrate. Those are example is tryptophan dihydroxygenase. Some coming to the hydroperoxidases, acts with the H2O2. So peroxidase is glutathione peroxidase and catalase. Dihydroxyoxygenase, it catalyzes the removal of hydrogen the substrate based on the H2A acceptor. They classified follows: aerobic dihydrogenase oxygenase. Oxygen is the acceptor of hydrogen. Anaerobic dehydroxygenase is the coenzyme act as a acceptor of NADP. NAD is linked dihydrogenase and NADP linked dihydroxygenase and FAD linked dihydroxygenase. This aerobic dihydroxygenase, these are flavoproteins and the product formed mostly hydrogen peroxidase. The example, the xanthine oxidase and glucose oxidase. Anaerobic dehydrogenase hydrogen acceptor as are coenzymes when the substrate is oxidized. Substrate is here is oxidized. The coenzymes is called as reduced state. We are coming to the electron transport chain. This transport the electron reduced substrate to oxygen is called ETC. That means electron transport chain. Inner mitochondrial membrane, like some of the components here required. Those are the nicotinamide nucleotide and flavoprotein and ubiquitin, that is coenzyme Q. Ubiquitin is nothing but coenzyme Q, and cytochrome A, B, C. These are the A1, A and A3, C and C3 and D. These are electron transport chain arranged in the complex steps, increasing the order like tyrosine redoxide potential like 4.2 and NADH plus H plus, and NADH is coenzyme reductase, and some complex here is required. Coenzyme Q reductase, some succinate, coenzyme Q, and cytochrome oxidase. These are the requirements of electron transport chain. Some electron transport chain is what is major aim is here is ATP synthesis, or assumption is ATP synthesis complex. That means ATP is generated there. So integral proteins in the innermost mitochondrial membrane, it has two units of F0 and F1. F0 is act as protein channel and F1 has ATP synthesis activity. Complex of ETC, nicotinamide nucleotide and flavoproteins, that is FADH and FAD. Coenzyme Q, that is also we will discuss about coenzyme Q, that is ubiquitin. And cytochromes also here involved. Fourth one is cytochrome oxidase. PO ratio is number of atoms utilized in the to synthesize the ATP for one atom of oxygen is required here. The PO ratio is NAD plus H plus is 3. There are 3 sites of ATP synthesis. The ratio is 2 sites of ATP synthesis here. Theories of oxidative phosphorylations. Chemical coupling is generations of ATP at substrate level, and second one is conformational coupling, that is in the molecules in the mitochondrial membrane leads to ATP generation. Chemiosmotic theory, the proton gradient generated during the electron transfer is utilized for the ATP synthesis. these are the steps or sites. We will discuss about the sites. Is the NADH plus, that is coenzyme Q, retinone and penicillin and amyloperidone. These are the inhibitors of the electron transport. That is the first site. First site is some of the inhibitors. Here is inhibiting the electron transport. That is first stage here. Retinone and penicillin and amylobacter, like barbital is British anti-levelic acid. These are the decreases in some second stage, so that cytochrome B, and third stage is that carbon monoxide here. Here is cyanide. These are the inhibit the cytochrome 3 cycle. So inhibitors of oxidative phosphorylations, uncouplers and 2,3-dihydrogenitrophosphoryl, and physiological uncouplers are the unconjugated bilirubin and thyroxine and aspirin, long chain fatty acids. Some of the oligomycin blocks with the ATP synthesis activity, and the atrocyte blocks with the proton flow into the mitochondrial matrix. So like that we will discuss about today. We will discuss about the electron transport chain and bioenergetics and high energetic compounds and low energetic compounds and electron transport. Finally we will conclude with the electron transport.